Hello everyone, this is Mr. Appel, and today I'm going to show you how to factor by grouping. This is quite a cool technique for factoring that can be really useful. So here's an example. So you'll notice one thing different here is there's actually 4 different terms. So none of the other kinds of factoring that we've done so far is really going to apply. So the technique that we use here is, we call it grouping because we're basically going to split this problem into 2 parts temporarily. So if I just look at the part on the left, right, just the 2x cubed minus 8x, I'm going to take the greatest common factor of both of those terms. So the greatest common factor, the GCF of 2 and the 8, is 2. And then the variables, there's an x cubed and an x squared, so I can factor out an x squared. And that leaves me with an x, because 2x squared times x is the 2x cubed. And then that leaves me with minus 4. Okay. And I'm going to do the same thing on the right side. So on the right side, the greatest common factor between those 2 terms is just a 3. And then if I factor a 3 out of the 3x term, I'm just left with an x minus, and then 3 times 4 is 12. And there's a plus 3 there because it's a positive 3. And now what I notice, and this is where it gets pretty cool, is that each of those terms has an x minus 4 as a factor. And so what we have here is 2x squared times x minus 4 plus 3 times x minus 4. Now if this was 2x squared times q plus 3 times q, we could factor out a q, because they have a q in common, and rewrite that as q times 2x squared plus 3. Well, it's the same idea here. The only difference is that that common factor is a binomial term. But we can use the same idea. I'm going to factor out the common factor that they have in common. Redundant there. The factor they have in common is the x minus 4. So there's an x minus 4 in common. And then what's left from the first term is just the 2x squared. What's left from the term on the right is just the plus 3. And that is our answer. You can always check to make sure you did it right. If we were to multiply that back out, you would in fact get the original problem, which means that this is factored correctly. That's all for now. Thanks.